Hey everyone, welcome to Show and Tell. And if you haven't been here before, our Show and Tell is a live stream where the team shows and tells you about the latest, greatest open source project or concept at TBD, because we love being open about what we're working on. So during the show, whether you're on Twitch, LinkedIn, YouTube, or Discord, you can drop questions in the chat and we will answer them in the second half of our show. So I am your host and moderator, Tanya, and joining us as our speaker for the day is Kendall. Say hi to everyone and feel free to quickly introduce yourself.
Hello, everybody. My name is Kendall. I'm a software engineer that works at TBD. And yeah, I contribute to open source technologies. That's what I do.
Awesome. All right. So whenever you're ready to get started, what is your topic for the day?
Okay, cool. I'll go ahead and share my screen. We have a slide, but I'm kind of hoping that a slideshow, I'm kind of hoping we can just make this somewhat conversational or storytelling. You should be able to see my screen right now. Yeah. Okay.
Yep.
Yeah, cool. So the topic today is what we call Rust core. And the tagline is build once, bind everywhere. And we're going to get into what that means exactly. The roadmap for today, I've broken it down into 4 parts. So the first part is, what does Rust core mean? What exactly is this thing? Part 2 is some of the technical details for the technically inclined individuals. Part 3 is the current state of the project and sort of next steps, so project management. And then we'll finish off with a demo. There's a lot of stuff to say here. This is all open source. We'll link to you'll see links throughout the slide to the projects. A lot of this stuff is very much work in progress, in motion. We welcome contributions. So feel free to, what you're going to hear today here is somewhat of a snapshot of a lot of work that's occurred over the past six months or so. So let's get into it. Okay, what does Rust core mean? So I think it would be useful to start with like a historical context. And that historical context at TBD is we have a number of open source projects. The 2 that are relevant to Rust core are Web5 and TBDex. And throughout the history of TBD, we've implemented these SDKs in a number of different languages. So the exact history we have to track through, but I believe it was like, first we implemented things in TypeScript, then we implemented things in Kotlin, then we implemented things in Swift. We have this whole developer website with a whole bunch of documentation around these implementations. Then we implemented it in Golang, and then we implemented it in Dart as well. So that's 5 different implementations of the same SDK across multiple languages. And I mean, the reason for that is that we're trying to maximize the adoption, right? So the different technical shops have different preferences, and they use different languages and different sets of toolings. And so if we were to just implement TBDex or Web5 and JavaScript or TypeScript, then we may not grow the initiative to the level of if we had broad support. So with 5 different implementations, we had a lot of, that's a pretty big maintenance burden. For one thing, it's like a lot of work. If you make one change to one specification, you have to go implement it in 5 different languages. You also have to make sure that the implementations interop. So they have to be able to work with one another. And so you can put test vectors, but once again, it's just like this huge surface area of a project that we're trying to increase efficiency of. So the idea is you could build it once in one language and then bind it to all the other languages. And the way I think about this is it's kind of like the sort of it's somewhat comical metaphor, but you can imagine like a a local economy that's very artisanally based. So you have a bunch of local shopkeepers, and the local economy works, but it doesn't really scale past a certain point. And if you want to scale it, you kind of have to embrace like manufacturing, right? So the idea is we're sort of building, the way I describe it is like we're building a manufacturing plant for SDKs. And there's a sequence of events that's quite literally like an actual an actual assembly line. So you do one, you do step A, then you do step B, then you do step C. So at a high level, that's like my hand wavy introduction to what's going on here. Is we write the code once, and then through some sort of magic wizardry software engineering, it sort of works across many different languages. So you can imagine how that solves some of our problems in the historical context. The relevance of this initiative to open standards is obviously we have a lot of open standards work that we do here at TBD. And one of the problems with open standards is you have a specification, which is a natural language, and it has test vectors. Typically, it has programmatic hooks in it, but it's sort of loosely subjective. So you have to take a specification and then you have to create a concrete implementation. So going from like the abstraction to the concrete, oftentimes there's difference of interpretations. There's like different things around the margins, which leads to, if you have one specification with many implementations, which is historically how most open standards work, you have a problem of interoperability between the multiple implementations. Like they may be spec conformant insofar as that they conform to the precise test vectors in the specification. But oftentimes there's like some superfluous or extraneous feature sets that developers actually need that may not be like broadly interoperable across implementations. So there's always this problem of going from the abstractions of the specification to the concrete implementation. If you standardize the implementation through a Rust core, through a single if you build it once and bind it everywhere, then you solve all these problems out of the box because everything is tightly coupled. Everything is interoperable by default. So through this initiative, you solve some problems around open standards, specifically around interoperability. I also think that there is something to be said about governance with open standards, and that governance around open standards is very decentralized. It's very ad hoc in a lot of ways. Different initiatives have different styles, and again, through the differences of opinions, it can often yield results in the actual concrete implementation which differ broadly. And so I think that there is something to be said about forcing everything through a single line of implementation that affects governance in a certain way that I think is productive, actually. So there's a lot of relevance to the open standards work we do. I also think that there's relevance to enterprise use cases here. It's a little bit of a tangential to our open source initiatives, but oftentimes things that originate in open source are uptake. They move into the enterprise. So enterprises oftentimes have there's different use cases in the enterprise, but one that really comes to mind is like oftentimes enterprises have like mobile applications, web applications, and cloud applications. They typically will span multiple platforms. And oftentimes there is like core business logic that is redundant across every single platform that an enterprise needs. And once again, it's the same problem of if you implement it multiple times, you can have problems of correctness, like it doesn't quite work totally. It's hard to keep everything totally lockstep in line. So I think, once again, similar problems to open standards. If you sort of streamline the implementation in enterprise use cases, I think you get some efficiency improvements. Okay, that's at a high level what Rust core is. The idea is we write it once and then it magically works everywhere. It's not really magic, obviously. So yeah, so some of the technical details of how does it actually work. I'm going to go ahead and just click through all these so you can see them all at once. So again, I'm describing it as like an assembly line. So there is a sequence of events, and I keep having this thought coming into my head that I wanna promote, which is I would call design-driven development. So oftentimes you hear test-driven development. I think the idea here is actually you first and foremost, you say like, what does a developer need? Like, and how do they want it? Like, we're used to viewing graphical designs of like, Figma designs and so forth. But the same can actually be true for like SDK products. It's not visual, but it does have an interface that the developer does need to interact with. So that's my shtick around design-driven development. Is the first thing we do is we figure out what the design needs to be, and once you figure out what the design needs to be, which is influenced by the specifications work, you then implement it through this assembly line. And crucial to that is you go ahead and define a set of unit tests as well. The unit tests are crucial because they lock in the actual interoperability between implementations. There's another level to this of test vectors. I haven't included that here. We do have test vectors, but they're not specific to Rust core. You can use test vectors in other use cases too. So the unit tests are very important for locking in interoperability across this sort of assembly line of implementations. So the idea is, first you define the design, then the unit test, then you write it in Rust. I'm going to talk about Rust here in a moment. Then you do some low-level computer science or computer engineering magic. It's specifically around what's known as the CFFI, which stands for Foreign Function Interface. And the moral of the story is like the C language. We probably all heard of C. C is broadly adopted across almost every single modern programming languages. In fact, a lot of modern programming languages are actually written in C. So they write the language, at least the compiler, in C. So everything has its roots in C is the moral of the story. And through that, you actually get interoperability across languages. So you can write something in Rust, and then you can build it to a C shared library. And then you can take that shared library and you can call it from Python or Golang or any other language through that CFFI. That's the wizardry in the middle. It's not actually the only interoperability mechanism that exists. There's other low-level bytecode solutions, but C is hands down the most broadly adopted interface to interop with. So you write it in Rust, you compile it to a C binary, and then on the other side, you read the C binary. You basically wrap it in some language, like some Kotlin specific language or Python specific language, which then calls the C bytecode. So why Rust? So it's called Rust core, but technically we could have written this in a number of different languages. Like I said, almost all languages interop with C, and so technically you could do this from any language. It's just a matter of difficulty. Like you could technically write it in Python and then compile it to C library, and then read it from Rust, right? But Rust is uniquely suited for this initiative. Golang was considered. It's right up there with Rust. They both have a lot of this similar qualities, which make them good for this initiative. Rust is, I think, slightly preferred for this use case because of the memory safety. And I'm not a huge Rust expert here, so I don't want to come off as I am, but memory safety is a big deal in Rust because problems which typically arise at runtime can actually be determined at build time. And that improves the development efficiency by a lot because you have tighter feedback loops. Instead of writing code, building it, deploying it, running it, and then figuring out you have an issue. You write the code, and actually typically most IDEs will be constantly building it while you're writing your code. And so you immediately figure out if you have an issue. Obviously, it's not a perfect solution. You still have issues that do occur at runtime, but because of memory safety, you figure those issues out a lot quicker. That was a big differentiator between Rust and Golang. But just as equally as important is that Rust has a little more maturity in the world of binding across languages, specifically around WebAssembly. WebAssembly is actually pretty mature. It's a pretty mature offering these days, and it has its roots in Rust. So I'm not a WASM expert, but my understanding is that the WASM, it's almost all Rust. So the idea with WASM is that the original idea is that you write Rust and you can actually run it in your browser. So you can compile Rust in such a way that it's then actually used in web applications. So yeah, between WASM and Unify, and there's some other things out there too. There's existing community support, which makes Rust uniquely suited for this use case. So yeah, that's why we chose Rust. I love Rust. This was the first project I used with Rust, and I've come to love it. It's like, wow, the Rust is amazing. I want to do everything in Rust now. Okay, those are some of the technical details, some of the lower level stuff. Let's move on. Okay, part 3, current state and next steps. The current state is we have TBDEX and Web5 mostly implemented in Rust. TBDEX, we have all of it implemented. Web5, we're almost done, like a week out probably. And so we have both implemented in Rust and both actually bound with Unify into Kotlin. So we also have the Kotlin offerings. So I'm going to actually poke around in the TBDEX repo here in a moment when we do our demo, so we can see some actual code. But yeah, the current state is we're pretty far along. I mean, in terms of getting the core implementation done, and we have one target language which we have bound to, and that language is Kotlin, sorry. And we're kind of ready to like, okay, now we're ready to like go into a lot of different languages. I said before it was like magic that you sort of build it once and then it kind of works everywhere. It's not actually magic. It does take work. You do have to actually write some code. It is on net. It is a lot less work. And once you have sort of all the plumbing in place, it's like rinse and repeat. So yeah, we're kind of at the point where the next steps are, we're thinking like, what are the next languages that we want to go into? Oh, I'm just realizing I wrote Flutter here, but I meant Dart. Dart is the language. Flutter is a framework. The next languages we're eyeballing are Dart or Flutter, and Golang, Swift, and TypeScript. We're thinking Dart is probably the next best option. For a number of reasons, one of which is that we found a new tool that's not Unify that is built by the Dart open source community, which is very good at this particular use case of cross-language bindings from Rust. And so we're eager to try that out. But also DidPay is written in Dart, so it'd be really cool to actually run the code in a different project, our different open source project we have here at TBD. Also, I gotta say, I'm not a Dart guy by any means. Like, I have hardly ever programmed Dart, but the Dart open source community, I'm very impressed with it. So that's definitely attractive. That's definitely appealing. Obviously, we have old SDKs, namely Swift and TypeScript are the other two, which we have robust developer guides around. So those would be those would be like high priorities just to improve the original problems of like maintenance burden. So I'm hoping by the end of year, like my expectation, my goal as the DRI on this initiative is to replace TypeScript, Swift, and Kotlin by the end of year. TypeScript is definitely a stretch goal because TypeScript we're going to run into a number of performance related issues around bandwidth, because oftentimes when you bind, browsers require high performance, and so you need low bandwidth resource assets. And oftentimes when you bind things, they're large. They're like on the order of many megabytes. Anyway, so TypeScript may be a stretch goal, but that's the goal. We are doing a Hacktoberfest, and the Rust core initiative will be part of the Hacktoberfest. I have it on my list of things to do to aggregate a list of ideas that I could propose for contributions during Hacktoberfest. So keep an eye out for that. Obviously, this is all open source, so you can go poke around in these repos today. We've been kind of in move fast and break things mode, so we haven't really done a lot of project management, for good cause, in my opinion. I would rather be writing code than writing tickets. But so if you poke around the repos today, you probably just need to go straight to the code and try to understand what's going on in the code. However, in the coming months, there is going to be a dedicated initiative to try and formalize more project management related items. Okay, yeah, that's the current and next steps. I'm going to pause for a moment. Tanya, do we have anything that we want to talk about before we go into the demo?
Yeah, good call out. Because there are like one or two questions that immediately came up, and people are also typing that I also had. To start, have you seen other open source orgs take this approach?
Well, I think that's an amazing question. There is one open source initiative which I'm familiar with that has taken this exact approach, which is Bitkey, which is a fellow block initiative, and they are actually using Unify for some of their core cryptographic logic. They offer both an Android and an iOS application, or at least they're aiming to. I know they offer an iOS currently, so they're using this exact mechanism for writing that cryptographic logic once and then having it work across both Android and iOS. By the way, the same thing would be true with what we're building here. There's a lot of other initiatives like this. It's a really hard problem, so I don't think there's not a ton of this going on right now. In some ways, I think what we're doing is pretty novel. So in that sense, it's pretty exciting. If people do have other open source projects or other open source orgs that have taken this approach and they're aware of it, and I didn't call it out, I would love to hear it. And so feel free to let us know in Discord or wherever.
Yeah, definitely. And I would say like interoperability is definitely a very, as you said, difficult problem. It's not like as magical as you mentioned that this initiative sounds. There's a lot of work that's going into it, and that's why you're in like build and break things mode. And a follow-up question to add to that: what's the reasoning behind binding one language at a time with Rust rather than doing them all in one soup? You may have mentioned this, but just in case to reiterate again.
Yeah, that's a good question. On some level, it is kind of all in one swoop, but it's in so far as that we are building a C library that is interoperable with everything else. However, it's not a sufficient developer experience to just offer a C library. Like, it's very obscure and esoteric to be able to load a C library and call into it. So what we're aiming to do is not sacrifice on any of the developer experience that we've come to know and love, like all the idioms of each unique language, while still interoperating or gaining all the benefits of Rust core. So yeah, basically it's like we can build a C library, but then we have to spend some time writing a sort of a wrapper project around that C library in the target language, which handles loading and also displays the developer experience in a standardized format. We could do that in parallel. I mean, we would need right now that bottleneck of in the technical sense of the C library is a pretty low level task. And so I'm sort of I'm the knowledge expert right now, but I think there are ways to parallelize it. And on some level, we certainly will parallelize multiple different implementations in the coming months. So yeah, it's not all magic. It's there's some low level stuff there, which is difficult to understand.
That's awesome. And thank you for answering that really cool question. Um, I just want to highlight Angie saying "grr" to TypeScript. It's pretty funny. Um, and another follow-up question I had that's most interesting to me from this entire initiative is what kind of testing strategies do you employ that maybe are different without this Rust core based approach and this focus on interoperability? Because that seems like the immediate thing that comes to mind for me and maybe for other developers as well.
Yeah, that's super important. On some level, we have an existing suite of test vectors that are actually applicable to our old SDKs. And the test vectors are really good for core logic, which is really, it's like pick the top, 30 most important things that are, we have to have these things or else we're not really conforming to the specification. Test vectors like that they're already integrate, like you can already integrate them into the old SDKs and this SDK or and this solution. It takes a sufficient amount of massaging. Like you have to take the test vector and then write some test code, which massages it into place so it fits perfectly into place. So we are doing that, and that's really good. And we will actually continue to do that, and we'll continue to grow the test vector suite. What I've been focused on recently, which I think has a place as well, is like I said, that unit test suite. So test vectors are more so these are the features we're testing. Unit tests are much more atomic. They're this is the specific behavior, given this optional parameter is not defined, I expect this outcome. So the way that is actually only applicable to a Rust core initiative. So it wouldn't really span across implementations because they don't really have a standardized API design. So yeah, right now, the idea is we write an API design proposal, which is we want to change this function signature to include this parameter. That gets approved. Then we have to codify the semantic unit test case. So it's if you add that feature, there may be 5 additional unit tests which need to be added. Those are actually codified in the code base. So it is like a programmable codification. And then you write the Rust code, which hooks into the unit test, and then you bind it, let's say, to Kotlin, and then in the Kotlin side, you also write the unit test, which hooks into the original unit test. So that's if you have full unit test covers, it's hard not to be conformant, interoperable at that point. Yeah, some ways it's overdoing it. In some ways.
Well, that's awesome. And thank you for that very in-depth answer. So one last question before we go into the demo here from Pete. Any new security concerns when exposing Rust via CFFI? Like loss of some of Rust safety, for example?
For sure there is. Yeah. I'm not a SecOps guy, so the low levels of security, I don't feel qualified to comment on. There's definitely additional security measurements which have to go into place. In terms of the memory safety, yes, that I can't comment on that one. That one you have to be really careful because the binary is built in a way such that it itself is memory safe, but if you misuse it on the target side, you can you basically negate the memory safety. So fortunately, with right now with Kotlin, we're using Unify, and Unify actually code gens the loading of that binary and the interfacing of it with it. But you could imagine if we were to build our actual CFFI bindings, you'd have a ton of unsafe interfaces, and you'd have to make sure that, for example, if you are referencing a pointer across the FFI, you clean it up after you use it, right? Like I said, fortunately, we don't have to go to that level of depth currently because of existing open source tooling does a lot of that for us. But but yeah, if you to your point, like if you build the bytecode library, even though it's memory safe in Rust, if you misuse it in the target language side, you don't have memory safety guarantees at that point. So yeah, it's a great question. Yeah.
Awesome. Alrighty. Ready to jump into the demo?
Okay, demo time. Let's do it. I'm going to present my screen.
And like we mentioned earlier, chat, whatever questions that you have, feel free to drop them in. We will be answering more questions either during or after the demo.
Okay, Tanya, you can see my terminal right now? Yeah?
Yes.
Okay. Is it the right size?
Seems to be. You can maybe make it a bit more. There you go.
One bigger. Okay. So I'm going to give a demo here in a moment. It's not going to be a super exciting demo, unfortunately, because it's not like a GUI. It's not a graphical user interface. It's just like a command line demo. But it's still a demo nonetheless. But before we get started, I did just want to sort of poke around the repo a little bit, just so people are somewhat familiar with the idea here. Right now, it's actually architected such that it is a mono repo. So we are sort of envisioning that every single language's implementation actually lives in this repo. I say right now because there is a potential future date where that becomes unwieldy, and we have to split it up into multiple repos. But yeah, currently it's a mono repo. So the way this is the TBDex repo. We also have the Web5 repo, but I'm just going to focus on TBDex for the sake of this demo. They both follow roughly the same patterns, fortunately. So the way it works is the two. Well, I'll just sort of I'll go through the assembly line. Actually, we have a doc which is called API Design, and it's a giant Markdown file, which is effectively it's the API design in a custom DSL. A lot of this stuff is still, I think we can improve this. I'm not like super confident this is the long-term solution, but this is what we mean when we say API design. API D is it's currently a Markdown file with all the various abstractions. And so if you scroll through here, you'll see like enums and classes with data members and constructors and methods. All of these concepts have to span every single target implementation, which is a trick in and of itself in finding a syntax which works across every single language. And it's a little bit as an art, like it's not a science, a little bit as just an artwork. There's no programmatic hooks into this. This is just, right now it's strictly for design. So it's strictly just to get us thinking about how exactly it looks. So that's the design. Oh shoot, actually I don't have unit tests in TBDex yet. I've been working on that at Web5, but the unit tests would actually go inside of this test directory. And right now it's just as simple as codifying a JSON file with the test name. That's sufficient for me for the time being. Offering more than that, I think, is a lot of overhead. But basically, you can imagine it's a list of unit tests. So it's like make sure that you have this unit test, that unit test, and that unit test. In terms of actually asserting the validity, it's up for developer review. Okay, so step 1, API design. Step 2, tests. Step 3 is in crates. Inside of crates, TBDex only has one crate right now, which is the TBDex SDK. This is, of course, the actual Rust source code. So if we go into let's go into RFQ. Here's a request for quote. Obviously, in all of its glory, here is a bunch of Rust code which implements an RFQ. So that's in crates. So step 3 is crates. Step 4 is specific to this particular target language. We're using Unify. So we have a Unify crate in the bindings directory. So we have bindings, TBDex Unify. This is a Unify specific project. So you'll see in the cargo, you'll see the Unify dependency. And we're currently using UDL. I think we should actually be using procedural macros, but at the time procedural macros weren't quite ready. Anyway, the point of this crate is that you're building unified bindings. This thing actually builds the C library. That's the point of this crate. And then there's a bunch of UDL code there. So that was step 4, I think. And then step 5 is we have a bound directory. And inside of bound, currently we just have KT, but you can imagine other languages existing in here. So here's KT. And this is just like this is a Maven project, right? So we have a pom.xml. And then obviously we have a source directory. What's interesting is I'll call out the source directory has a resources, which is a well-established pattern in the Java world. And this is actually, this dylib file is actually the bytecode file. Like this is the C library that gets built. There's a lot of detail around it, specifically called Arch64 Apple Darwin, because you have to build targets for different architectures. But that's where that lives. And then we have like our tbdex wrapper code. I want to just quickly show tbdex wrapper code, and then we'll move to the demo. But what I mean by we have to we still write wrapper code. This is what I mean. So it's just like a simple, we still define the inputs and outputs the same. That's the importance of the API design and the unit test, is the inputs and outputs are all identical. But then if you read the actual inners of it, you'll see calls to Rust core. So we basically take the inputs. In this particular instance, we actually JSON stringify it. I won't go into that. There's some details there. But we take the inputs and then we basically call the Rust core interface, which is what was built from Unify, right? And then after we call the Rust core, we basically, it's like a giant system of mapping. You're basically mapping into the Rust core, calling it, and then once you get the result, then you map back to your given Kotlin type. So with this solution, we still maintain all the Kotlin idioms. We maintain all the great little features of building the language in the specific language. But the actual contents of the Kotlin code is just it's just wrapper functions. All of it's just a bunch of wrapper functions. Okay, that's just poking around the code base. Now let's get to the demo. The demo I want to show is, I wrote this application. It's in the examples directory. It's called Hosted Wallet KT. And it's a tbdex hosted wallet. So the idea is that we have both a PFI and we have, keep an eye on time, PFI as well as a wallet application. And the idea is it's like a full sort of happy path. There's no actual money movements. There's not even a database on the PFI. It's all just in working memory. But at a minimum, both projects use the tbdex KT Maven artifact that was in the repo or the directory I just showed. They both use that Maven artifact to make the tbdex calls in order to do a full transaction, from start to finish. So let's actually, I'm gonna real quick go into the code. I'm gonna do something very dangerous and try and make a code change before the demo. So this demo has multiple flows, and I just want to change the flow to, aha, there we go. Okay. I usually program in IntelliJ for my Kotlin programming, so this is funky. Okay, so I wanted to just change it to just one single flow instead of, there's a whole bunch of flows here, but I just want to simplify for the sake of the demo. I need to split the terminal, go into examples, hosted wallet, and then I need to, in this terminal, I'm going to run my PFI. Hopefully this is large enough for everybody to see. And then in this terminal, I'm going to run the wallet. So before I run that, just real quick, the basics is this will be a polling flow. So if we look at the code, you can see this is the polling flow. The first thing we do is fetch offerings and create exchange and so on and so forth. here you can see like these are the actual calls into the Maven artifact, which is using the Rust bindings. So this is like actually using the Rust bindings to fetch an offering and then create an exchange and so on and so forth. So that's the point. Looks like our PFI is running, and let's see if I mess something up while it runs. All right, nice. Fetching offerings, found an offering, creating the exchange. There we went. Okay. Exchange created. So that was the RFQ. Received a quote from the callback, submitting the order, received order instructions. These are the order instructions. Then received order statuses, pay in settled, initiated, payout settled, and the close received and exchange completed successfully. The demo worked. Good job, everybody. Okay, that's it. That's the demo. So we used the Rust bindings to complete a full TBDEX exchange. That's it.
That's awesome. And as Roselle mentioned, that's very dangerous of changing the code live, but you're definitely an expert at demoing now. You can say that.
All right, nice.
Yeah, so any questions, anybody? In the meantime, I wanted to know before anybody else asks anything, have you seen any real world, like whether it be use cases or personal impact, like significant impact, where this approach to interoperability has made a huge impact already as you're working through it?
Well, interoperability, I can't say for sure yet because
Yeah.
we've only bound to one language. But what I can say is that there was a feature we had to implement sort of, and I was pressed for time. I wasn't actually sure I was going to get it implemented. And it was a change that had to go through the full flow, right? So it was like one new feature and it had to go through every single step. And I was able to do the entire flow, which the end result is a Rust SDK as well as a Kotlin SDK in under an hour. So in under an hour's time, I was able to do everything. And I can tell you from experience, like with our prior SDKs strategy of having multiple implementations, that's probably more like a 2-day thing because you're talking about multiple individuals, the multiple coordination, everything working together. So I've definitely seen an undeniable improvement in efficiency so far. Yeah.
Yeah, as Angie mentioned, she can attest that this will make consistency across the SDKs much, much better, which is always awesome. Nicola asks, is this P2P or peer-to-peer?
Yeah, I mean, all the Web 5 stuff is peer-to-peer. So it's in that spirit, and the TBDEX stuff. So
Yeah.
it's an SDK. It's not like we don't have like it's not the equivalent of like running a node. We have talked about building node related software for some time, but this is just the SDK layer. But it certainly can be used for peer-to-peer purposes, and we hope that that is the case actually.
Awesome. I actually had a question of my own too. Let me just post it here. How does this focus on open standards specifically contribute to better interoperability for this initiative and our SDKs, for example? For anybody that in the audience that may not know as much about open standards.
Yeah, so with open standards, you typically have a specification document which is written. It's almost like a legalese document. Like it kind of looks like an attorney wrote it almost. So it's not actual code, right? And then it's up to the developers to then take that specification and then make it concrete. And the specification, for it to be considered a non-draft specification, does have to have sufficient technical information in there that there is no ambiguity. However, what I'll say is that inevitably, when you translate from that sort of abstraction of the specification document to the actual implementation, whether or not it's a bug or whether or not it's a feature is sort of beside the point. If you have multiple implementations during that process, you end up with, it's difficult to get 100% interoperable between multiple implementations. So the idea here is that you just have one implementation, and so it's like interoperable out of the box, right? And so there should be no ambiguity whatsoever, actually. Yeah, hopefully that got to your question.
Yeah.
Okay.
Thank you. Definitely did. And then let's see here. Another follow-up question I had, this is the lengthy version of it, but how do you manage, or have you seen performance differences, if there are any, when running the same code across the various platforms and language with this?
Okay, this is an excellent question, because this is a hurdle that has to be jumped over.
Yeah.
In terms of, like a pro here is that you have only one implementation, and so you can really optimize the algorithmic efficiency of the given implementation, right? So you don't have different implementations where you have one algorithm over here and different algorithm over here that both produce the same results, but they do it in different performance characteristics. So the pro here is that you do have the luxury, the benefit of only having to have a single algorithm, which you can really optimize. Okay. The con, which is much more real and much more difficult it has to be addressed, is that oftentimes when you bind to these C libraries, like these bytecode libraries, the binary file that gets produced can be quite large. And so, for example, like the tbdex dylib file, which is for Apple Silicon Macs, I think it's about 8 megabytes, and 8 megabytes is pretty beefy. It's too beefy for a web environment. I mean, it's a matter of debate, but I would say it's probably too beefy for a web environment, but it's fine for a mobile environment, right? So basically, the answer to your question is like, it's circumstantial. Like, you got to take it on a case-by-case basis and figure out what you're targeting. It's fine for mobile, because typically with mobile or a desktop, you're just downloading the thing once and then it's on your local machine and you're just constantly reusing it. Whereas browser specifically is really challenging, because whenever you load a browser page, you are almost always refetching the assets from the remote. So you're re-downloading them on every page load. Obviously, there's caching and stuff which can improve these things, but generally speaking, that's the challenge of browsers. So that's why specifically TypeScript is difficult to target. Although I would say that TypeScript is also a server platform. So if we were building it for a server environment, we don't have to concern ourselves with the performance characteristics. Maybe you do to some degree too. It kind of depends on the server setup. But yeah, anyway, that's the answer. Is it's a case-by-case basis, and there are ways to optimize these things. So like, it's by no means a showstopper. I can't just sit here and be like, TypeScript's never going to be an option because it just always will be too large. There are ways to optimize it. It's just a matter of difficulty and how much work you have to put in to make it feasible. Yeah.
Yeah, no, that's a really good answer. A follow-up question from Nicola, as in the middle of that, is how small is the SDK if packed into a binary, say with Tori or CLI?
I'm not sure what Tori is. I think he may be referring to, okay, Tori is a framework for building tiny, blazing fast binaries. Well, maybe I should look into that. I can say that the Maven artifact for tbdex KT right now, I think, is about 40 megs, which is already kind of too large in my opinion. It's doable, it's fine, but we should find ways to improve it. I zipped up, it's a lot smaller than that, so I actually don't know what the zip size is. It's interesting that you brought up CLI too. I'm not sure. I think you may be referring to a specific tool there, which again, I'm not familiar with, but
yeah,
I will say that we do have a CLI tool as well. And I was going to see really quick if I could pull up what the size of that build is. Let me see.
As you pull that up, Rizal mentioned Tori is an Electron alternative. Okay.
That makes sense. That makes sense. Okay, I don't have it built right now. It would take a minute to. Oh, just kidding. I have it right here. Okay, wow. So this is amazing. So check this. The Web5 CLI executable is only 136 bytes. That can't be right. How is that possible?
Wow.
I think that it is on the order of that magnitude, but perhaps I may be misreading something. But this these build systems, it's all just like a case by case basis. It just depends. Like you can optimize certain things, and other things are really beefy. So
yeah, maybe you can join our Discord and ask more, or we can help answer more to that question too. This is another very specific follow-up from Nicola as well. Do you sideload the SDK and the quote-unquote server, or just the SDK? 136 bytes for the world.
I know, if it's 136 bytes, that's amazing.
That's amazing, yeah.
Sideload, I'm not really sure, to be honest. I'm not sure. I'm not familiar with sideloading. I can tell you that for example, the Kotlin Maven artifact, which is the one I'm most familiar with because that's the one I've been working on recently, is it loads it at runtime, right? So the binary is actually embedded in the jar file, and then the code will, upon startup, it will load it into working memory. So there's no like special. Again, you could optimize stuff here. You could I'm sure there's native calls to cache loading, so you don't have to load it on every single load. Right now, it's just big and slow because it works.
Awesome. I know we're nearing the end of time, but let's go to some other questions. So from James, because I know you mentioned WASM before, have you considered compiling your library to WASM components that also allows generation of native bindings for any language that can target WASM components?
Yes. So I haven't spent enough time on this, to be honest, but we ruled it out because Kotlin does have WASM support, but based off of the preliminary research we did at the time, it was sort of insufficient relative to the Unify offering. However, I will say, after working with Unify for some time, I'll be happy to try an alternative. Unify has been great. I mean, I really appreciate Unify. It does a lot of things out of the box. But it's been a lot of work, actually, when I was hoping it would be less work. I will say that Golang, I think, does have a pretty mature WASM offering, is my understanding. So if we do go to Golang, which, by the way, that's going to be probably one of my Hacktoberfest items, is to bind it to Golang, is I would definitely explore the WASM angle a lot more. And awesome. One more thing too, we did actually, this was maybe 6 or 8 months ago now, so my memory is blurry, but we did do some WASM into TypeScript for just like simple hello world type of applications. Nothing as robust as or as feature rich as the Web5 SDK. And we were able to optimize it down to where it was usable with TypeScript. However, it did take quite a bit of work. So anyway, yeah, I'm so into WASM. Like, I know WASM has a lot of community support, and it's pretty mature at this time, is my understanding. So it's definitely on my plate of things I would like to look into here.
Awesome. And not final, but another follow-up from James, who asked the question. He mentioned, yes, Go probably has second best support next to Rust. Kotlin and C family langs are not quite there yet.
Yeah. I'm so in. If we can do WASM to Golang, I'm in.
Yeah, that'd be awesome. Otis asked a question earlier. Have you tried Nappi RS, which is a Node.js and Rust binding implementation?
I did try that. I prototyped it when I was just getting started on this like 6 months ago, and it did work. Yeah, I remember that. I'm actually myself, I'm a vanilla JS guy. I don't like TypeScript. I like just vanilla JavaScript. And that, when I was doing my research for that, that was the solution which came up, and it did, if I recall correctly, it worked like a charm. So I don't know if it would be feasible for browser environments again, just because of the size of the bytecode file. But yeah, I'm into it.
Angie too. She loves vanilla JS.
Yeah,
All
exactly.
right. Any other questions, anybody, in their last 2 minutes? I actually had a follow-up question in the meantime. You mentioned earlier that this is your like first experience with Rust and how you grew to love it. What were the main reasons why?
The memory safety just cannot be, it just can't be beat. The memory safety, because your IDE will actually tell you while you're writing your code if you're effectively going to run into a null pointer type of situation. I think that, from the outside in, when I remember back to like a year ago, I had never written Rust. And I remember reading Rust and I was like, man, this seems very esoteric and like a verbose language. And I still think that's true, but it's like the type of thing where once you get over the hump of like, yeah, you have to do like some weird things around memory safety to make sure that you're not, violating a memory safety rule. It kind of just becomes second nature, and it seems much less of a friction point. I do think that I'm still of the opinion that Golang is probably the most widely applicable language these days, like for most use cases. However, for this particular use case, I think Rust is the best choice. And yeah, I would still prefer Rust over Golang, like myself, but you do get some additional baggage there too. But yeah, I'll say that. Sorry, one more thing too, which is that I first learned to program in C and C++. Like those are my first languages. And there was something about like, I went on this long arc of, I started in C and C++, and I used all these modern programming languages. And then now I'm like back to Rust, and it feels like going home. I'm like, oh, I love it.
'Cause it became a character arc in a way.
Yeah. Yeah.
One very final question. We're just at time from Otis. What are the hurdles when you use an API?
I don't recall, honestly. I think there was an issue. I think the issue that I was concerned with was just the size of the bytecode file, because you have to build I think if I recall correctly, with an API, you are loading the actual bytecode file, whereas WASM compiles a dedicated binary file, and so they can do optimization improvements. But honestly, I didn't push it that far, so I would be curious to see if people wanted to pick that back up and push it to its limits, and see if it's a low hanging fruit, then we should just do it. Even though WASM's there, if it's low hanging fruit, we should just do it.
Yeah, maybe it's something that can come up in our Hacktoberfest. So yeah.
Yep.
All right, everybody. So, after this stream, thank you so much for joining. If you have any other questions or anything like that, feel free to join our Discord if you're not already in it. That's where you can get in contact with us directly. So whether it's a question on this or any of our other initiatives or our SDK specifically, feel free to ask. And yeah, so long, everybody. Bye.
See you.